Okay, so for our bell work today, we're going to have an ACT prep problem. This is Journal 9 if you want to label your journal. So if you're trying out this problem here, we have this polynomial, and in this case, it wants us to factor. So it wants us to factor this polynomial, which just means that can you take this 2x squared minus 3x minus 5, and can you have it in those parentheses where you're finding those numbers that go here and here. So that's talking about, can you put this polynomial as a factor form? So the thing about this, we could try to factor it, but there is a 2 in front of the x, okay? So one of the things that we learned to help us out here is something that's called slide and divide. So when we slide and divide, we are taking the, gosh, I can't spell here. Let me fix that. So when we are sliding and dividing, we're taking the 2, the number in front of the x squared, and we're multiplying the number that's at the end, so that negative 5. So that means that when we multiply, that number drops off from the x, so 2 drops off, so it's just x squared minus 3x. 2 times negative 5 is negative 10. And then from here, we can go ahead and try to factor. So remember, we would have our x in front, and we would ask ourselves, what 2 numbers multiply to give you negative 10, but add to give you negative 3? And you guys probably say, like, 5 and 2. So maybe negative 5 plus 2, because when you multiply those two, you'll get negative 10, but when you add them, negative 5 plus 2 gives you negative 3. So this works out. Here's the thing, these are not your factors. What you have to consider is that because you multiplied by 2 in the beginning, to undo multiplication, you have to divide. So we have to divide each term by 2. And so when you divide each number here by 2, the second one here is nice. 2 divided by 2 is just 1, so x plus 1. And then this one here, notice how 5 and 2 don't divide very nice, right? And so you might have learned in Algebra 2 that when it doesn't divide very nicely, you put it in the front of x. So that means you have 2x minus 5. And so the answer here would be, let's see which one of these two has one of the factors. Looks like h, x minus 5, x minus 5. So h here is the correct answer. All right, we're going to move along to our lesson for today. We're going to go back and learn something called 30-60-90 triangle and 45-45-90 triangle. So we're going to tune into our geometry skills. Okay, so back in geometry, you learned something called the 30-60-90 triangle. It's basically a special type of right triangle where both sides, well, this side here is 30 and this side is 60. Remember, a triangle needs to add up to 180 degrees. So your teacher might said, the short side, and the short side's usually, the short side's always with the 60 degrees. The short side is always x, some value, and let's call that x. And when you take this short side, the hypotenuse, this hypotenuse here is always double the amount of the short side on a 30-60 triangle. So I'm going to get my marker here. So it's always double the amount, so I can say that's 2 times x to say that that's double the amount of this short side. Then this longer side here, it's really weird. It's actually x times the square root of 3. I will explain why these are the cases when we take a look, or why this is the square root of 3 when we look at example A. So let's take a look at example A together. So in this example, what I've done is that I've given you one of the sides here is 1. And we have to find the other 2, and we can use this formula to help us out. So I'm going to use this formula to help us get this side because, remember, if this is the shortest side, this hypotenuse is double that amount. So in that case, this side here, 1 times 2, is going to be 2. So this is going to be 2 on this side. Now, on this side here, I know if I were to make this like my x, right, if this was x, then 1 plug in for this x times the square root of 3, this would be the square root of 3. But I want to show you guys why this is the square root of 3 by using the Pythagorean theorem. We can use the Pythagorean theorem if we want to find out a missing value, right? So in this case, I have 3 of the values. I have the hypotenuse, so r squared equals x squared plus y squared. So I have the hypotenuse, so that's my r. So that's going to be 2 squared equals, okay, so from here I have 2 squared, and then I'll just say, I don't know what x is. X could be what we're trying to find. And then y is your 1. So this would be 1 squared. And so 2 squared is just 4 equals x squared plus 1 squared is just 1. So then I would have to subtract 1 from both sides. And so this would lead me to x squared equals 3, right? And then I would have to take the square root of both sides. Well, the square root will cancel out with the x squared. And so now I'm just left with x is equal to the square root of 3. And that is going to be our value here, which is the same thing if we were to plug the 1 in for this x, right? So this here is the square root of 3. Now let's try this one here, but just using the formula. So I hope that this one here showed you how that became a -3. It's just, or not became a -3, a square root of 3. It's just from the Pythagorean theorem when you work it out. Because of those ratios, it's going to result with a square root of 3. So this side here, notice how the shortest side here is 4. So that means that this side here, the hypotenuse, is double that amount. So if x here is 4, this side here would be 8 if it's double. Then this side here is x square root of 3. Our x is 4, so 4 square root of 3. And now I have all the pieces, okay? Oops, my bad. There we go. So I have all the pieces right there. And I'm done. Let's take a look now at the 45, 45, 90 triangle. So in this triangle here, I have a 45-degree triangle. And so the thing about 45-degree triangles, if the angle is the same on this side, and let's just call this side here, you know, a value x, right? Let me use black. So this side here is x. Because these two are the same angle, this side here also needs to be the length of x. And then if you want to find the hypotenuse, well, the hypotenuse based off the sides here would be x square root of 2, which looks really weird why that's a square root of 2, but I'll explain using the Pythagorean theorem, just like how I did with the last one. So with this problem here, one side is 1, so this side here would also have to be 1. And if I wanted to find this side, I could plug 1 in and multiply that by the square root of 2. I could do that. But I want to show you real quick how you can find the hypotenuse using the Pythagorean. So this side here is your r, right? It's your hypotenuse. So you would have your two sides, which you have to square and then add. So 1 squared plus 1 squared is 1 plus 1, which is 2. This side would just be r squared. Take the square root of it. R is equal to the square root of 2. And notice how that is the same result as us plugging 1 in for that x. So we have the square root of 2 on this side. Okay, then on this side here, if this is a 7, then this side's also a 7 because we said a moment ago that 45 degree, when they're both 45 or the angle's the same, we have the same sides. Basically, we have an isosceles triangle. So in this case, they're both 7s, and then I have to find this side. I'm going to skip using the Pythagorean, so I'm going to plug if our x here is 7, right? So if one of our side length is 7, our x value, I plug that x value in, so 7 square root of 2. And that's it. So, since we've learned quite a bit, I want to talk about angles, triangles that have the same angles but different side lengths. So I'm just going to go find the trig. Let's do tangent. So I'm going to do tangent 45. So it doesn't really matter which 45 I choose. It'll give the same results. So I'm going to choose this 45 and this 45. So I'm going to start out with this angle here. So 45 degrees, if I want tangent, that's TOA, or opposite over adjacent, right? So if this is opposite over adjacent, I'm going to have, let me erase that now. Opposite is 1, adjacent's 1. So that's going to be 1 over 1, which can be reduced down to 1. And so this here is my answer, or my ratio for tangent 45. And then if I do tangent for this 45, even with different lengths here, this one's a 7, I still do it the same way. It'd still be tangent 45 degrees equals 7, the opposite, over 7, the adjacent, which is still, if you reduce, 1. Notice how both of these answers, even though they're different sizes on the triangle, so the lengths are different, because the angles are the same, their ratio is going to be the same. So, moral of the story, when you simplify, let me say it like this. So they are the same ratio when reduced or simplified. And that's just because that their angles are the same. So it really doesn't matter what the side length of your triangle is. It just matters if the angles are the same. Anyhow, let's try some homework problems here next. So in this chapter, I've assigned problems from chapter 15.1, 45 to 68. And so in here, these problems are specifically on a 30-60 triangle. So I'm going to draw a 30-60 triangle here so that way we can look at one for reference. So if this is my right angle, let's say that this side's 30-60 on this side. Remember that this side here is the short side. And you know what, I'm going to draw that better so that way you guys can see that this side's the short side. So 30-60. So what we're going to do here is we need to find the trig value, so of the ones that they've given us, but we need to find the exact value. So what it means by the exact value is, do you know the ratio for that trig value? So in this case, if I want to find tangent of 30, I need to go to this angle and find, you know, my sides. So let's just refresh for a sec. SOHCAHTOA. So I'm going to put this up here to help us out. But here's the thing, they never gave me a triangle to work with. Okay, so what I have to do is take my triangle. By the way, that is not a 68, that is a 60. I think my degree sign is starting to make this look like a 80. There we go. So when I'm looking at this triangle here, what I want to do is, because they didn't give me a triangle, I'm going to make a triangle to work with. Because the thing is, the trig ratio doesn't matter, doesn't care about the lengths of the triangle. It will all result in the same values. We saw that before in the last slide. So in this case, I can just choose what my triangle is as long as I follow that definition of what it means to be a 30 and 60 triangle. So let's make this easy on ourselves and make the x value that usually goes here, or the shortest length here, to be 1. So if this side's 1, remember the hypotenuse is double that length, so this hypotenuse here would be 1 times 2, which is just 2. And then this side here would just be the 1 times the square root of 3, so that's just the square root of 3. If this doesn't make sense to you, make sure you go back to that, the notes in the previous slide, so the one about the 30, 60, 90 triangle. So now that I have all my sides, I'm going to find tangent. Tangent is opposite over adjacent. So if this is opposite over adjacent, on the 30, so this one's 30, that's going to be 1 Let's see. Opposite would be 1 over the adjacent, which is the square root of 3. So 1 square root of 3. Ooh, but I have a square root in the bottom, so I need to multiply the top and bottom by the square, but that square root, so that's the square root of 3 on top and bottom that I'm going to multiply. Whenever we multiply two things that have the same square roots, the roots cancel, bringing out the number underneath. And then 1 times the square root of 3 is just the square root of 3. And then there we have it, our ratio. Because now the 3 is no longer in a root. All right, let's try the next one here where we're finding sine. So sine is opposite over hypotenuse. So that would be, we're still using the same angle, but opposite would be 1 over 2. So sine would be 1 over 2 because it's opposite over hypotenuse. So that's it. That's my answer there. And then our next one here is going to be sine of 60. So 60 is on this side here, right? So if this one's my 60, you want to look at that opposite. So the opposite of the 60 degree is actually the square root of 3 now over the hypotenuse, which is 2. So that's going to be the square root of 3 over 2. And that there, notice how the root there is not in the bottom, so I don't have to rationalize that problem. This here is my answer. And so those are my trig ratios for that given degree. It's just using a triangle. I recommend using one that is very simple, where maybe the x value here was 1, and then using that to find the other sides. So the nice part about a 30, 60, 90 triangle is that if you have one side, you can find the rest. Whereas before we had to have two sides to find all the sides. Okay, so now let's take a look at triangles that have 45 degrees. So I'm going to draw another triangle here where it's 45 degrees, kind of like what we did in the last slide. So this is 45 degree right triangle. And because I need to find the trig ratio, so the sine, cosine, and tangent, I'm just going to write SOHCAHTOA up here again, just so that way we have something to look at for reference. So if I have these two angles here, I can build myself a triangle, and I'm just going to make it a really simple triangle by making, one of the sides to be 1. So if I know that this is a right triangle and 45, if this side's 1, this side's also 1. And then we also said that the hypotenuse would be just x, the square root of 2. So our x value here is 1. So 1 times the square root of 2 is just the square root of 2. And so make sure you go back to that one of those first slides so that you can figure out what all the formula for the 45 degree angle. Okay, so from here I'm going to find secant. So remember that secant is the reciprocal of cosine, right? So if it's the reciprocal of cosine, cosine is your adjacent over hypotenuse. So that means that secant needs to be flipped. So that's going to be hypotenuse over adjacent. So let's take a look at our 45 degree angle, and you can pick either one. They're going to give you the same results because the sides are the same, right? So in this case, our hypotenuse is the square root of 2. So I'm going to grab the square root of 2 and put that in my top. The bottom here, the adjacent would be 1. So I'm going to put that in my bottom. But isn't the square root of 2 over 1 just the square root of 2? So we can simplify that just a little further. And then our next stop here is cotangent of 45. So cotangent is the reciprocal of tangent. And so if we look at tangent, tangent's opposite over adjacent. So in that case, cotangent has to be adjacent over opposite. So if we work this out, our 45 degree, our adjacent is 1, our opposite is 1, so 1 over 1, which can be reduced down to 1. And now we have our trig ratio. And last but not least, we got that sine is 45 degree. and sine is just our opposite over hypotenuse. So our opposite in this case would just be maybe a 1, right? 1 over our hypotenuse, which is the square root of 2. But here's the thing, I have a square root in my denominator, so no good. I need to multiply the top and bottom by the square root of 2 to rationalize. So if I multiply the top here, I get the square root of 2, and the bottom, if I multiply, the root cancels, so that's just a 2. And so I have the square root of 2 over 2. And there we have it. Okay. So hopefully we've gotten quite warmed up with our 45, 45, 90 triangle and our 30 and 60, 90 triangle. So we're going to fuse those two ideas here in our next slide and try to find all sides of the triangle. Okay, so behold, I've given you this triangle here where this has a 60 degree, this has 45, and I only give you one side length. And you have to figure out the exact value for each of the variable that's labeled, and the variables are representing the side lengths. So what it's asking you to do is first, let's take into account what type of triangles we have here, right? So if this side's 60, then this side has to be, well, actually, let's go on this side. This one's 90, right? So this side also has to be a 90. So I'm going to just do a little box here. So if this is 60, that has to be 30 degrees. And then if that's 45, well, that has to be 45 here. So we have a 45, 45, 90 triangle, and we have a 60, 30, 90 triangle. Given that, let's focus on the side that we already have. So we already have the 24, right? So if we already have the 24 here, on the 60-30 triangle, let's review a little bit of our 60-30 triangle that we drew earlier. So the formula for 30-60, so the smaller side, 60's, the bigger angle is up here, with the smaller side being x. The hypotenuse is double the amount of the smaller side, so 2x. And then on here is the x times the square root of 3. So based off of this here, we are going to find maybe these two lengths here, the A and the B. So first ask yourself, okay, if this is 24, the hypotenuse, right? The shortest side, which is this side here, should be half of the hypotenuse. So that means that A here is half of 24, which is going to be 12. Half of 24 is 12. And so this side here, which is the next longer side, B, would be taking this value, the short side, which, so you can pretend that the short side here is your x value, right? So if x is 12, you're going to be plugging into here and multiplying by the square root of 3. So my B here is 12 square root of 3. And so now I have all the sides to this triangle. So I'm done with the 30, 60, 90 triangle. On this side, if this side here, right, is 12 square root of 3, that means that this side here is also, oh my bad, is also the 12 square root of 3. So that's what I'm going to write here, 12 square root of 3. And then this side here is our hypotenuse. So let's just review real quick about the 45-degree triangle. Well, that's not a very good 45. So 45s basically have the same sides length, but then the hypotenuse is the square root of 2x, so x square root of 2. So if x here is this side, which is the square root, 12 square root of 3, then our c here, our c is 12 square root of 3 for plugging this all in for x, but then I have to also multiply by that with the square root of 2. So if you were to multiply these two, multiplying roots, you would just multiply the numbers underneath. So 3 times 2 gives you the 12 on the outside, and the square root of 6. And the square root of 6 I can't break down, so I'm going to keep it under the root. And so there we have it, our last side, our C value. And that's it. We found all sides of our triangles. So that's it for this lesson.